Okay, for the LU methods, so we have three methods under the LU method. So first, Doolittle. Second, Thomas algorithm method. And the last one is Cholesky method. Okay, alright. So for the LU method, why this method is called as the LU method? Because of if we have the matrix A, so we change to LU method. So what is L? L is the lower triangular matrix, and U is the upper triangular matrix. So after we separate A equal to LU, and then LY equal to B, Y can be Y1, Y2, Y3, and the value of B is here from the equation. After we get the value of B, and then we solve UX equal to Y. So now we can get the value of X. Value of X, let's say X1, X2, X3. We solve the value of X. Okay, alright. Okay, so for the first method, Doolittle method. Okay, for the Doolittle method, so we have to separate A equal to LU. Okay, so A equal to matrix of A, so L is equal to the diagonal for the Doolittle method. The diagonal should be equal to 1. The diagonal must be equal to 1. 0. This one lower, right? So this one can be A, B, and C. Okay. So this is L, and for the U methods, the other number. So this one can be D, E, F, G, H, I. So other element will be equal to 0. Okay. Now you multiply between these two matrices. Multiply. So you get D. E, F, AD plus G, AE plus G, AF plus H, BD, BE plus CG, BF plus CH plus I. Okay, so for the Doolittle matrix, so your L matrix should be, the diagonal should be 1, and for the upper triangular matrix, your U is the other element in the matrix A. Okay, so we will use this matrix to compare with the value of element, with the value in our matrix A. Okay, right. For example, so we want to solve this equation by using the Doolittle method. Okay. So our matrix A is equal to 2, 3, 0, negative 5, 2, 1, 0, negative 7, 1, X, Y, Z equal to 2, 1, 1. Okay, so this is from the equation. So this is matrix A, X equal to B. Okay, so the first step what you need to do is A equal to LU. So the matrix A 2, 3, 0, 1 equal to LU. So just now we already multiply this the two matrix of LU, DEF. Actually, if you want this equation, I think you don't have to memorize. But if you want to memorize, okay, it's not a problem. But after this, a lot of formula that you need to memorize, kan? So I think for the Doolittle method, LU you don't have to memorize. Just multiply between L and also U. But if you want to memorize this formula, it's not a problem. Okay. Okay, now we compare. So now we compare D is equal to 2, E is equal to -5, and F is equal to 0. So AD is equal to 3, so D will be equal to 1.5. BD 0, so B is equal to 0. AE plus G equal to 2, so G is equal to we don't have the value of A. This one is A, not D. So 2 minus with 1.5 times with E. E is equal to -5. So the answer is 9.5. Okay. So AF plus H is equal to -7. So H is equal to -7. And then what else? We have A, B, C. C, we have to find C. So BE plus CG equal to 1. So C is equal to 1 minus with BE, 0, and then minus with CG. Divide by C. What is the value of G? 9.5. 0.1053. And then the last one is BF plus CH plus I equal to 1. So we want to find the value of I. So 1 minus BF, 0, minus with CH, H, 1.7371. So now we have all the value of A, B, C, D, E, F, G, H, and also I. So we already have all the value of A until I. So now the next step is step number 2. We need to solve Ly equal to B. Okay, so our L matrix, the diagonal is 1, and then A, B, C. What is our A? B, and also C. Yeah, they will be equal to 0. So Y, Y1, Y2, Y3 equal to B. B just now is equal to 2, 1, 1. Yeah. Okay. So now we can use the forward substitution. So by using the forward, we can start from the first row. So we have Y1 equal to 2. So second row, so 1.5 Y1 plus Y2 equal to 1. So Y2 is equal to 1 minus 1.5 Y1 negative 2. And the last row, we have 0.105 Y2 plus Y3 equal to 1. So Y3 is equal to 1 minus 0.1053 times Y2, 1.2106. Okay, and then the next step is U upper matrix times with X equal to Y. Okay, so upper matrix U, so we have D, E, F. U is D, E, F, G, H, and also I. Here there is 0. X. So we want to find X, Y, and Z equal to Y. So Y1 is equal to 2, negative 2, 1.2106. Okay, so you can solve this equation. You can apply the forward substitution like just now. This one backward substitution. So you can start from this row, or maybe you can use the calculator to find the value. Menu alpha A, simultaneous equation. So 3 equations, 2, negative 5, 0, 2, 0, 9.5, negative 7, negative 2, 0, 0, 1.7371, 1.2106. So your X1, therefore, from the calculator, X1 is equal to 1.7575, X2 equal to 0.3030, and XYZ. And your Z is equal to 0.6969. So this is your answer. Okay, actually from this step you can also use your calculator. If you want to apply backward substitution, so with forward substitution, okay, and also if you want to use calculator also can. Okay, so this is the answer. Right. Okay. I have these questions. maybe you can try. My answer is x is equal to -1, y 2.5, and sec x is equal to 3, y to 2.5, and sec equal to -1. Okay, maybe you can try later. Right. Okay, so now Thomas algorithm method. So for the Thomas algorithm method, first of all, your matrix must be in the tri-diagonal matrix. Okay, your matrix of A must be in a tri-diagonal matrix. So only at these three diagonal have the value. You have to rearrange your matrix so that you can get the tri-diagonal matrix. Okay, if your matrix is not in tri-diagonal, so you have to change the row lah. You have to change the row until you get the tri-diagonal matrix. After that, you can apply the Thomas algorithm. Okay. So this is all the formula in the Thomas algorithm, and this formula will be given in your exam. So no need to memorize, just follow the step. Just follow the step. Okay. Right. Okay. Right. So let's try. Basically kan, when to apply the Thomas, when we want to solve the system that has more than 3 equations. For example, we have 4 equations or more than 3 lah. Then we can apply the Thomas algorithm. Okay, so let's try. Okay, so we put in the matrix of A. In the matrix A, so we have 2, 1, 0, 0, 2, 3, 8, 0, x, y, z, w, x, y, z, w. Okay, now refer to this matrix. So this is already in the tri-diagonal matrix, so you don't have to do anything lah. For example, they give you this one as the first equation. Okay, so when you rearrange, so you get x, y, z, w, x, y, z, w, x, y, z, w, x, y, z, w, 2. Okay, so look at this matrix. If we look at this matrix, okay, if we look at this matrix, so this is not triangular. Yes, this one we have the value, we have the value, but the problem is here. So this is not the tridiagonal matrix. That's why you have to rearrange your matrix until you get the tridiagonal matrix. But for our case, for this example, here is already in the tridiagonal matrix, so you don't have to do anything lah. Just use the formula. Okay, so this okay, let's try. So this is our C. C is 2, 3, 4. Before that, for the Thomas algorithm, you have to construct this table. You have to construct this table. In the list of formula, they will not provide this table. They just give you the formula. This formula. I think this formula like this. So you have to construct the table, and the number of column depends on the number of the variable. Let's say For our example, we have X, Y, Z, and W. So we have 4 variables. So you need to put 5 columns, including this one lah. So 1, X, Y, Z, W. Okay, I repeat the number of column is depends on the number of the variable. So start with C, D, E, B, and so on. Okay, now our C. What is C? 2, 3, 4. Okay, so you cannot start from here. Just now 2, 3, 4. Okay, and D. What is our value of D? D is 2, 3, 1, 2. Okay. So 2, 3, 1, 2. And E. What is the value of E? 1, 8, 2. 1, 8, 2. There is no value here. Okay, and what is our value of B? B is 6, negative 6, 2, 5. 6, negative 6, 2, 5. 6, negative 6, 2, and 5. Right. Okay. So alpha 1, so follow the formula. Alpha 1 will be equal to D1. So equal to 2. Okay. So 2. So the others number of I, number of 2. So you need to use this formula only for the alpha 1 equal to D1. But here, if you want to calculate here, you need to use this formula. Okay. Alright. So D2 is equal to 3 minus with the C2. 2. Okay, again D2 is our D2 minus with the C2 and then multiply with the beta 1. So no choice, we need to find the value of beta 1 here. So beta 1 is equal to E1, 1 divided by alpha 1, 1 over 2. So 0.5. Okay, now we can find here, because we need the value of beta 1. Okay, now D2 minus with the C2, 2, and then multiply with the beta 1, 2.
Disconnected.
2. Okay, and now find the beta 2. Beta 2 equal to E2 divided by alpha 2. So equal to 4 lah. So here will be 4. So find here 1 minus with 3 times with 4, negative 11 beta E divided by alpha negative 0.1818. So we don't have to and then D2 minus with the 4, negative 0.1818, 2.7272, but we don't have the value here. Okay, right. Okay, now we need to find the W. So only the W1, we have the value of W1 with the formula B1. So 6 divided by alpha 1. So we get 3. Follow. So now this is our next calculation. So B2 is negative 6 minus C2 multiply with the W1. 3, and then divide by alpha 2. Negative 6. Okay, here. So B3 BB equal to 2 minus with C B, and then multiply with the W 2 6, and then divide by alpha 11. So negative 1.8182. Okay, now here, so B B is 5, with C is 4, and then W negative 1.8182 divided by alpha is 2.7272. 4.5001. Okay, so our next target is xn equal to wn. Okay, xn, so xn equal to wn, so start with the x4. 4 is 4.5001, so 4.5001, and then find the x3 equal to W3 negative 1.8182 minus with beta, so plus 0.1818, multiply with the x4. That's why we need to find x4 first. 15001 negative 1.1230. Okay, and the next one we need to find the x2. So x2 W2 negative 6 minus beta 4, and then the previous x negative 2, and x1 equal to W1 minus beta times with the previous x, so equal to 4. Okay, right? So this is your answer. The 4 x1 or x
power off.
X equal to 4, y equal to negative 2, z equal to negative 1, and w is equal to 4.5001. So this is your answer by using the Thomas algorithm. Thomas is quite complicated. That's why they give you the formula and you just need to follow one by one. Okay, just follow the step. Okay. So the second example. So let's write the matrix of A. So x1, x2, x3, x4, x1, x2, x3, x4, x1, x2, x3, x4, x1, x2, x3, x4. Okay. Now if we look at this matrix, this is not triangular matrix, tridiagonal matrix. Okay, so what you need to do is you need to rearrange. So this one can be this one will be your first equation, second equation, third, and also fourth equation. Okay, now when you rearrange, now you can get 1, 3, 0, 0, 2, 4, 6, 0, 0, 3, 7, 4, and the fourth one is 0, 0, 4, 3. Okay, now you can get the tridiagonal matrix. Okay, so you need to rearrange your matrix. Okay, right? Maybe you can try, and my answer is x1 equal to 2, x2 equal to 0, x3 equal to 0, and x4 equal to 2. This is my answer, but you need to check. Okay. Right. So the last methods under the LU method is Cholesky method. So for the Cholesky method, the matrix of A must be in symmetric, positive, definite. It must be symmetric, positive, definite. Then you can apply the Cholesky method. Okay. So what is symmetric, positive, definite? So symmetric, positive, definite. The matrix of A should satisfy all these properties. So the first one, the matrix must be non-singular, means the determinant cannot be equal to 0. Determinant is not equal to 0. And then the diagonal matrix must be positive. And then the maximum at the diagonal, the maximum values at the diagonal must be greater than the maximum values other than the diagonal. And then aij squared must be less than when we multiply ai with the aj. So this is the properties under the symmetric, positive, definite. Okay, after you check all these properties, then you can apply the Cholesky method. Okay, right. So for the Cholesky method, similar like the Doolittle matrix, you have to reduce your matrix to the A and also A equal to LU. But for the L is equal to this matrix A, B, C, D, E, F, G, H, I, J, and U A, B, C, D, E, G, H, I, J. The arrangement you have to memorize A, B, C, D, E, F, G, H, I. But for the U, A, B, C, D, E, F, G, H, I. Okay, you have to memorize the arrangement. Then similar like Doolittle, we find the value of y and then find the value of x by using the ux equal to y. Okay. Okay. So A equal to LU, A, B, A, B, C, D, E, F, and U, A, B, C, D, E, F. Okay, and then multiply these two matrices. A squared AB AD AB B squared plus C squared BD plus CE and then AD BE plus CE and then D squared plus A squared plus F squared. Okay, so you're going to have this matrix. So as you can see, this one is similar. Okay, this one is similar. Right, okay, so let's try this example. Show that the matrix A for the following linear system is symmetric, positive, definite. Then show the solve the system by using the Cholesky method. Right, okay. Symmetric, positive, definite. So the first one is the determinant. The determinant is must be not equal to 0. So you can use your calculator. You can use your calculator to find the determinant, or you can just do it manually lah. For example, like what you have learned in your EM1, but my suggestion just use your calculator. Okay, so 2, negative 1, 0, negative 1, 3, negative 1, negative 1, and 4. Option, matrix, and determinant. Negative 18. Negative 18, that is not equal to 0, so the first property is satisfied. So the second one, the second properties, the diagonal should be positive. The diagonal matrix must be positive. Then yes. Yes. Okay, the third properties is the maximum. The maximum at AII, the diagonal must be maximum at the maximum, not at the diagonal. Right, okay. Now, so we look at the diagonal. So that's the maximum is 4. Okay, now we focus at the element, not at the diagonal. So we have negative 1, 0, negative 1, negative 1, 0, and negative 1. So we can see the maximum. The maximum is 1 because of absolute value. Here, we can see that the maximum at the diagonal is greater than the maximum at the non-diagonal. So satisfy. Yes. And the last one, and the last property is AIJ squared must be less than when we multiply with the AII with the AJJ. Okay. So AII, A12, we have A12, A13, and also A23. Okay. Right. So let's check. A12 squared less than A11 multiply with the A22. So A12 is equal to just now negative 1 squared less than A11 is equal to 2 and A22 is equal to 3. Yes, satisfied. And then A13 squared must be less than A11 multiply with the A3. So equal to 0, 2, and 4. So yes, and the last one, squared must be less than A 2 A 3 negative 1. If 1 squared less than A22 is 3 and A44 is equal to 4, also satisfied. Therefore, our matrix of A is symmetric, positive, definite. So you can apply the Cholesky method. Okay. So we find our A equal to LU. So matrix of A, we have 2, negative 1, 0. Negative 1, 0. Negative 1. Okay. So LU, when we multiply LU just now, so we have A squared AB AD AB, similar, right? Okay, now we compare. So now we compare to get the value of A until F. So A squared equal to 2. So A equal to 2 or 1.4142. Okay. Square root of 2. Okay, now AB negative 1, so B is equal to negative 1 divided by 1.4142, so negative 0.7071. AD equal to 0, so D equal to 0. B squared plus C squared equal to 3. So C is equal to minus with B squared negative 0.71 squared, and then third 1.5811. BD plus CE if 1, so E equal to 1 negative 1 minus B D divided by C 1.5811 negative 0.6325. And last one, DE plus E squared plus F squared equal to 4. So F is equal to 4 minus D squared, 0 minus with E squared. Set 1.8974. So we have all the value A, B, C, D, E, and also F. Right. So the second step we solve Ly equal to B. So matrix of L, ABC, A, B, C, ABC, D, E, F. The other equal to 0. Y, Y1, Y2, Y3 equal to B. -7, 6, 17. Okay, so now you can use your calculator. So your Y1, so from the calculator, Y1 is equal to -4.9498. Y2, 1.5812, and Y3 is equal to 9.4867. Okay, from the calculator you can directly get the answer. After that, the next step is, or the last step is, Ux equal to Y. So matrix A, what is our A? B, C, D, what is D, E, F. So the other will be 0. So x1, x2, x3 equal to Y. Now you can use your calculator. So x1 from the calculator, x1 is equal to -2 equal to 3.0132, and your x3 will be equal to 4.998. Sorry, for decimal places, so 4.9998. So this is your answer. Okay, so I repeat for the LU method. So for the LU method, we have 3 methods. first Doolittle method. For the Doolittle method, so A to LU, so this is the matrix for L. The diagonal should be 1. And then U, but don't forget the arrangement. After that, we compare to find the value A until I, and then Ly equal to B and Ux equal to Y. Okay, so for this part number 2 and 3, you can just use your calculator. And then for the Thomas algorithm method, you have to change the matrix A to the tridiagonal matrix. Okay, you have to put your matrix in the tridiagonal matrix, and then after that, you just apply the formula. Okay, the number of column, it depends on the number of variable that you have. And the last one is Cholesky method. So if you want to apply the Cholesky method, you have to check the symmetric positive definite. So it should satisfy all these properties. Then you can apply the Cholesky method. So this theorem will be not provided, so you have to memorize. And for the LU method, don't forget the arrangement for the L and also U. After that, apply the same formula like we do in Little. Okay, that's all.